To check if the encoder board in your SKAARHOJ device is working properly, you upload a small example sketch from the SKAARHOJ utils library. And that is called analog readout or encoder test. And this is the most basic one, and the other one is sort of polished a little more. Anyway, let me show you what they do. We have a C200 connected. It's an Arduino Mega inside, just to check that. All right, we upload. These sketches are usually configured as they should be for SKAARHOJ devices, so you can, for most parts, expect that values like which pins are used for the encoder is actually the correct ones. We use the same over and over again. Anyway, the point is here that you need to open the serial monitor as usual for these tests, and then it shows you this. And now I turn the upper encoder to the right, and every time you see this output. And now I turn it to the left, and you see this output. If I turn the lower encoder to the right, you see this output. And if I turn it to the left, you see this output. Okay, so what is happening here? Yeah, actually I'm intending to wait a bit by explaining in detail what this is you see. But the pattern that is important is you see 1, 0, then you see 1, 1, and then you see 0, 1, and finally 0, 0. This is the pattern you see right here. You see it right here as well. But you actually also see it here. You just see it kind of in the other way. I'll just clear the screen, and then you see 0, 1, then you see 1, 1, you see 1, 0, and then finally 0, 0. So it's like it's moving from the one side over to this side and ending up in zeros like that. This is the kind of pattern you should see all the way. It depends on which way you are turning. So here you can see the same, but here I turned the other way, and there you see 10, 11, 1, 0, but the pattern is clear. You have 2 1s there, 2 1s there, and end up with a 0 down there. Okay, so that's what this one should confirm to you. So what is the E1 and the E0? These indicate moments when the Arduino hardware interrupts are triggered, and you should usually only see one of these for each time. So there should be an E1 or an E0 for each time you have a division like this. Let's try to just turn the knobs a little quickly. Then you can see in the serial monitor what will happen. So I'm just turning it quickly here. And if I turn it quickly enough, you also see that this division line is missing. So you only see the division line if I do this slowly. And don't worry about that. If I do it really quickly, you're still able to actually see more or less the same pattern. So you just need to put some of the divisions up yourself. So you see there's, sorry, I think I'll just do it over again. And you have 1, 0, then you 1, 1, and 10, and 0, 0. So the division line should have been put here, and here the division line should have been put here. So it's the same kind of thing, and it's working. Okay, so that's the very, very basic level of testing the encoder boards. It simply reads out, prints the values on the digital ports that these two guys are connected to. The other sketch that will, on a slightly higher level, confirm the test is this one, encoder test. And again, let's see if there's some configuration to be done. I don't think so. So we should be able to just compile it right away and upload. And we open the serial monitor. And there we go. Okay, I'm gonna turn the upper encoder again to the right this time. I'm turning the upper encoder to the left. And I turn the lower encoder to the right, the lower encoder to the left. So what is the pattern again? Now, what it tells us is that the encoder has received one trigger signal, and it was the upper encoder called 0 that was turned to the right. And then later it received also one trigger signal, and the -1 tells us that it turned to the other side, also the upper encoder. So what we see here is a totally correct pattern that this is the lower encoder, encoder 1, which is turned to the right and then to the left. And Okay, the basic test here with this sketch is that you turn the knob to the right, you see that it's 1, left, -1, right, 1, dong, 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 dong. And if you turn it twice, you should see it twice, 3 times, 4 times, etc. And what I suggest is that you operate it forth and back a little bit to make sure that every time that you turn it slowly, and if you turn it fast, that you see that it catches the trigger signals and it also knows the correct direction. And you do the same for the lower slider, absolutely the same process. Now, if you are really quick, sometimes you'll see that it actually ends up showing you 5 trigger signals before it outputs that the encoder 0 was turned 1 time. So what it means is that the internal routine that checks the encoders will do it in an interval that has already received 5 triggers from the interrupt. And sometimes we actually use that in the menu generation of the units, so that if you turn an encoder really fast, then it will turn a value up with not just 1, but it will increment it with 10 or something else, so that you can quickly go through a large interval of numbers. Do this to make sure that the encoders know the correct direction, triggers correctly, and they should be fine. I would like to go back and explain to you who are more interested in how encoders work, why the encoder raw readout does or shows the output that we saw. So this is going to be a little more detailed. Bring up the serial monitor again. And we remember the pattern I was talking about from before. So now I have turned it, here I have turned it right, and here I turned it left, okay? And just to summarize the pattern, we see 0, 1, we see 1, 1, we see 1, 0, and then finally 0, 0. And we see the same down here, just the opposite way. I'll do that in green. 10, 11, 0, 1, 0, 0. Okay, now basically an encoder, a rotary encoder like this one, is 2 switches. So when I turn it just one step, then within that 1 step it's like a button push, like that. But the point of this button push is that if I turn it to the right, the button push of the 2 switches are offset a little bit. So let me show you that. Create a little timeline here. This is T. And then we have switch 1, and then we have switch 2. And the way we could draw how a switch changes is that it's 0, and then we push the button, and then it becomes 1, and then we release, and it becomes 0 again, like that. And this is what I tell you, that when you rotate a rotary encoder, it will work like pushing a button. The point is that the 2 switches inside the rotary encoder will deliver a button push which is offset in time, as you can see right here. So basically what we do is that we read the signal at this point. And when this signal goes from 0 to 1, the the interrupt 0 hardware interrupt is triggered. So that means in our software, it will now read, okay, what is the state here? What is the state here? And it finds that up here it's 1, and down here the state is 0. So that becomes 1, 0. Okay, a little later, at this point in time, it now sees that the second switch goes high, and now we have 1 and 1. So this becomes 11. And then we have another transition over here where in time we have 1, and then it's 0. So that's 1, 0. And then finally, the last transition we have is when we go back to 0 for both again. So, and there you have it. You have the pattern that we saw just before, 10, 11, 0, 1, 0, 0. And that's the same we saw in the serial monitor, 10, 11, 0, 1, 0, 0. So you see the opposite pattern when we turn the other way. So that's the point. If we, let's say, inverse the timeline, so instead of going in that direction, we simply turn it the other way, then we start out over here and see 0, 1 here, and then we see 11, and then we see 10, and finally 2 again. I'm sorry, I just need to go back here. So 0, 1, 11, 10, 0, 0. So that's if we are turning in the opposite direction with the encoders. And this is how we detect the direction of an encoder. It's simply to see in which way these offset signals are sent to the machine. And obviously, it's very important that we can make a readout of these values in a way that is secure or certain every time. And this is why we need to test the encoder boards. It will be extremely confusing if an encoder doesn't react to the particular direction you are turning it. So that's what we are obtaining, and the theory behind it.